Semantic digital libraries facilitate the usefulness of the traditional digital libraries by exposing the content of the digital library through a structure and interrelated web so that it can be easily used by both the machines and the users. This module discusses the core services that can be enabled using a semantic digital library, the architecture of semantic digital library from various perspectives, and example of some semantic digital library initiatives. Most of the digital libraries facilitate the searching through the RDBMS, which stores the metadata information of the digital library content, or by using a full text index to allow for searching of the contents of the digital library. These methods are helpful in browsing the digital library or retrieving the results by making a query based on the terms that are indexed from the digital objects, but not for retrieving results for queries where the query term is not included in the index terms or the metadata of the digital objects. For example, a user is looking for a book on orchids authored by Rolf in the digital library, having a book on vanilla authored by Rolf. This will not get the desired result. This is where the addition of semantics to a library can be very useful. Semantic information represented by metadata attached to each object and by one or more ontologies to provide semantic context for searches can be used to resolve exactly such queries. The additional flexibility and search capability represented by such a technique make a semantic digital library much more valuable than a traditional digital library for an average user. Sebastian Reisert-Kruk pointed out three problems faced by the digital library users as follows. Missing a librarian. Problems with information discovery and understanding complex metadata missing peers. They cannot share experience with other users visiting the library. Missing a connection with other sources. Library resources cannot become a part of the information processing workflow. A semantic digital library provides the options to make the digital libraries more useful in today's interlinked web by making the unstructured data machine readable. The major goals of a semantic digital library is to integrate information related to digital library objects available from various sources like bibliographic descriptions, user profiles, bookmarks, controlled vocabulary, among many others. A semantic digital library should allow for reuse of objects. This can be achieved by using semantics providing meaningfully connected information. It should also enable interoperability with other systems, including digital libraries and other services. Major goals of semantic digital library is to provide the following services: search, browsing, and recommendation services, services for augmenting resources, dissemination and notification services, security and policy assurance services, services providing interoperability, preservation services, quality assurance services, and integrated documentation. The major objective of a semantic digital library is to provide information discovery that is superior to the services available in current digital libraries. It should facilitate the users to find out interconnected information about resources available in the digital library while browsing, filtering, or finding similar information objects. Query refinement engines should use complex semantic relations between results to provide search results matching user profiles. Semantic Digital Library should also provide recommendation services. Example, based on the context and resource annotations, or based on collaborative filtering. The search engine should allow for exploiting information about different media types, complex objects, streaming, and spatio-temporal resources. In the case of resources with complex annotations, it is important to support content-based search together with similarity search algorithms. In the case of heterogeneous competitive networks of content providers, the Semantic Digital Library should implement query trading algorithms to support the users in their searching. Semantic digital libraries should enable the users to access the metadata in any format and through any services. The users should be able to access the content's metadata by constructing mashups of services and content. These metadata should be provided through APIs as a customizable RSS and ATOM feeds, SIOC, which stands for Semantically Interlinked Online Communities descriptions, RDF graphs, and in JSON format. To enhance the user experience, extensible and customizable notification services can be provided as a part of the information retrieval process. Semantic Digital Library should adapt to various policy enforcements and provide flexible authentication and access control mechanisms for convenience of the users. The Semantic Digital Library should provide interoperability standards for content, metadata, services, and protocol standards with both backward and forward compatibility. It should provide services compatible with both legacy standards. For example, DNST Z39.50 and OAI PMH, and modern protocols such as SPARQL or OAI ORE. Preservation services. A semantic digital library should ensure versioning, archiving, which includes backup and recovery, as well as provenance tracking, especially in the context of open world approach of semantic and social technologies, and also in keeping track of history of events related to information objects. Quality assurance services. A semantic digital library has to ensure efficiency, security, and semantics of maintained metadata. Semantic digital libraries and the related services are mostly complex in nature. It is a vital requirement from the perspective of the library usability to deliver documentation integrated within the digital library system. Kruk and his co-authors have provided the architecture of semantic digital library from three perspectives. Number one, top to down layered architecture. Number two, vertical architecture of core services. And number three, stack of enabling infrastructures. This architecture has been derived based on the metadata perspective and user perspective of semantic digital library. Semantic digital libraries posed requirements for new information discovery and management technologies and provided features like highly extensible faceted navigation, natural language based interaction, or community driven collaborative filtering, among others. The contemporary user interaction models, example Web 2.0, or instant messaging has to be included for the users. Benefits that users can derive from semantic digital libraries have to be delivered as enriched services over and above what is being offered to him or her by the contemporary solutions. In the semantic digital library, user profiles can be captured with a special ontology that describes characteristics, groups they belong to, and relationships with other users. Semantic DLMS can select only the desired part of information and process it to deliver a given functionality for a specific user. It became especially feasible with the underlying unstructured metadata and ontologies. Kruk has given a layered architecture for digital library management system, which is composed of 6 layers. The lower layers in the figure are more data-oriented, and the upper layers provided the requirements of the end users and external services. The service-oriented architecture is proposed to specify, organize, and execute services delivered by each abstraction layer. The 6 layers are client layer, data presentation, data preparation, data manipulation, data abstraction, and data source layers. The client layer represents applications used to access the digital library content, which include graphical user interface available through web browsers or mobile browsers, programs that process the content for their own purpose, or mashups that consume the content and provide through an integrated portal or service. Data presentation. The data presentation layer represents the endpoints which deliver the raw content to the client layer application and services. The data in this layer is expressed in different levels based on the standard of encoding, like some formats require more information and processing, while others can be directly sent over from the underlying RDF storage. This layer shows the benefit of using RDF object model and ontologies to define the meaning of concepts and relations. In most cases, a user does not need to know the particular schema in advance. If necessary, the specification required for transformation can be derived from these ontologies. In some cases, it is just a matter of reformatting the information to other standards like JSON. This layer assures that information modeled using concepts of one ontology can be translated and tailored to fit the understanding of other users and client services. Data preparation. This layer is quite different from the previous layer and acts as a checkpoint for the delivered content. It does not directly manipulate the data, but represents the data based on various policies and user requirements, or ensures the consistency of the data and augments with additional information from the same library or other services. Data manipulation. The data manipulation level is the most developed layer of the semantic digital library model. It retains the core mechanisms responsible for delivering particular library functionality to the end user. The layers above process the data to fit the appropriate client needs, while the layers below provide the means to perform operations needed to fulfill a given service goal. Details about this layer are explained in the business logic services layer. Data abstraction layer. The data abstraction layer provides atomic data operations for the data manipulation layer. This is the last level before accessing the actual databases and responsible for data consistency, its proper preservation, and access. It delivers an abstract object model which allows to seamlessly access and manage various data models. For example, RDF, full text index, and distributed index. Data source layer. The data source layer represents the data repositories used for the semantic digital library, which include RDF storage for metadata storage and conventional storages for binary form of the resources. It also includes full text index storage and separate services required for managing distributed and local data. The data manipulation services layer of the semantic digital library are presented in four vertical layers. These four layers are based on the role that they play in interaction with end users in the semantics digital library. Number one, information discovery, such as access, search, browsing. Number two, advanced management services. Number three, basic services. And number four, interoperability services. Information discovery services are the services the end user interacts with most often. The services implemented in this column range from enhanced search and browsing, natural language interfaces, faceted navigation to community services such as annotations, ranking, collaborative filtering, and collaborative search. Additional services support context-based operations, user profiling, and overall quality of service. End users can also interact with the DLMS to compose workflows to support their business needs. This layer includes collaborative search, collaborative filtering, annotations, ranking, natural language annotations, faceted navigation, natural language interface, query processing, search and browsing, context or profiling, quality services, and workflow composition. Advanced management services are mostly accessible by the librarians and library administrators. They deliver service, user, collection, and streaming media management. Librarians can also manage the set of ontologies deployed in the semantic digital library. They can also invoke ontology learning processes on the corpus of recently added resources. Basic services support core operations of the semantic digital library, such as content and metadata management, ensuring access and policy management, among others. A set of basic services support librarians in the classification process by indexing, feature extraction, and recognition operations. Interoperability services are farthest from the end user but close to the external services. To support interoperability, semantic digital libraries can offer different solutions. They range from simple exposing metadata and SPARQL endpoints to metadata harvesting solutions, for example, OAI PMH, to service and metadata mediation services. This section provides the architecture from the technology perspective in which all the previous layers operate. Service-oriented architecture. The service-oriented architecture suggests for providing the services of semantic digital libraries using web services, which facilitates effortless integration of digital library services in outer online services or mashups. This includes both the REST and SOAP services. Peer-to-peer. The peer-to-peer network infrastructure is used for data processing distribution. It is commonly used to create a distributed index for data stored on different machines. Grid. The grid networks are mostly used for heavyweight data processing tasks. The grid infrastructure can support digital library in execution of the most heavyweight operations like query processing, which is to be executed at the runtime, converting resources, processing annotations, and indexing that can be executed behind the scene. The semantic digital library should not deliver new features at the cost of lowered system efficiency. Therefore, grid networks can support processing annotations and semantic web languages query processing to maintain overall system performance. Semantic digital libraries are the next step in the evolution of current digital library management systems. They offer services which exploit the notion of semantics and cater to online communities of library users to keep up with growing demand on the quality of provided services. This chapter discussed about the various services that can be provided through semantic digital libraries and the core architecture in creating a semantic digital library.